The easiest way, and I know I kind of alluded to this earlier about how you start with a tangent graph, is if you go back to the unit circle and just look at the cycle of going around, you're going to see how it moves itself through. So when I look at a unit circle, we have our quadrantals, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. When we were looking at the angle stuff with tangents, tangent was only worked within pi over 2 to negative pi over 2. The reason that was is because what's the tangent at pi over 2? Well, it would be 1 over 0. It's 1 over 0, so that would be undefined, right? And it does the same thing at 3 pi over 2. The tangent at 3 pi over 2 is also undefined. So when you think about that terms graphically, when you have undefined functions, that means you have a vertical asymptote. So what we do is the following. In a tangent graph, we place asymptotes between at pi over 2 and negative pi over 2. What's the distance between those two? Pi. The distance between those is pi. So the period for a basic tangent function is pi. Because as soon as it hits pi over 2, it hits an asymptote and then it jumps around again. Now, think about what happens at tangent at 0. Well, if I'm at 0, tangent's y over x, which is 0 over 1. What's tangent at 0? 0. Good. But in order to make some sort of a curve, or like the other graphs had, we had those 5 points that showed us going up and down and back up again. Whereas tangent, only thing we know about is that there's two asymptotes because you can't divide by 0, and tangent goes through the origin. So think about another really, really easy point that gives you a tangent value. What about 45 degrees, pi over 4? What's the ordered pair at pi over 4? What's root 2 over 2 divided by root 2 over 2? 1. So at pi over 4, it hits 1. What happens at negative pi over 4? It would be negative 1. Also notice, what's the relationship between pi over 4, pi over 2, and 0? They're equally separate. They're half. Pi over 4 is halfway between 0 and pi over 2. So your graph looks like this, increasing from left to right, going through those 3 points. Hug your asymptote, go through the 3 points, and hug the other asymptote. Okay. Now that's when your A value is going to be positive. What do you think is going to happen if the A value is negative? Just goes the other direction. Yep. So when we're dealing with tangent graphs, we have a very easy setup. We have y equals A tangent B of x, where this value of A, we're going to call it the amplitude. It's technically not an amplitude. An amplitude is either a max or a min. Think of this point as where it changes direction. So it's a direction change. So it's our amplitude-ish. Is that okay to call it that? Is there anything else you could call that?
Yes.
It's the scaling. It's going to be how high up or how close to the origin it changes directions at that point. The B value still allows you to find your period. But tangent's period is the following. Period is going to be pi divided by the absolute value of B. Oh, we should probably put the absolute value out here too. A is positive, and if A is negative, it does that. If my original period for that graph we just looked at was pi, do you see how my asymptotes were at pi over 2 and negative pi over 2? The trick is your asymptotes will always be placed at plus or minus half of your period. Your vertical asymptotes will be at x equals plus or minus half of your period to start. That looks daunting, but once we label out a period a couple of times, you'll see how fast it is. It's really very, very quick to figure out. It's going to go through the origin because there's no shift. So once you have an asymptote and an origin, just cut it in half to get the next point. Yes, sir?
So then a quarter of your period is equal to the, what, 1?
Yeah.
Like that? Okay.
Yes, ma'am.
To start. So I mean, just start. So you might just that's your asymptote.
Yeah, when we start with the parent function.
Oh.
Because we're going to shift the asymptotes are going to move left and right, but the parent function will be at plus or minus 1/2 the period to start. And then we could shift them later with an H and K.
But when you shift it, is it still half of the
Yep.
period?
The period doesn't change, it's just moved.
Oh.
That's all.
Okay.
That's all it is. Chimkey?
Will our graph ever go through the asymptote? Like, will it have to
Yes.
go
When it
the
shifts-
overnight?
Yeah, what happens a lot of times is that your original function might have asymptotes, but the shift might land on the original function's asymptote, but that doesn't matter because the original one was just there to help us visualize what's going on. All right, and I have an example of exactly that happening.
Okay.
So it's not a big deal. Remember, your parent function is always kind of, it's just an image to help us figure out the rest.
Okay.
So what do you use to because sine and cosine are used to calculate wavelengths, aren't they?
I don't know, I can go off and tell you something, but I could be making it up.
Oh, okay.
I'm not gonna say it.
So that's what it's for. I made these.
That's actually time.
So much fun.
So much fun.
Stop watching basketball. Take your earphone out and put away your phone.
He's watching Yes, like it's not obvious.
Put it on my desk.
You mean like, yeah,
If it is slow, like
All right, let's look at a couple real quick non-shifted ones, then I'll do a shifted one and probably call it a day. What I'm looking at doing still tomorrow is I'm going to probably push the reciprocal properties till after we take a test on this. Because in the grand scheme of things, the reciprocal property technically is a pre-calc thing. I might just use it to stall for a day or so before spring break and not start the next unit.
yeah.
So I think I might do that instead.
You could like.
Nah, we're not gonna watch that. So first thing we do is we go through a listing of things. What's our A and our B? Our A is 3/2. Our B value is 4. Means my amplitude-ish is 3/2. And my period is going to be pi over 4.
do you have to put quotation marks on it?
If you like, air quotations are fun.
Can I write ambitions in a
Ambish, yes, ambish.
Ambish to.
Are you little bunny foo-foo hopping through the forest?
What did he
No, the got me. You got me. I got
Where's my phone?
All right, so we start with the non-shift. If my period is pi over 4, that means my amplitudes are going to be, the distance between my amplitudes is going to be pi over 4. The origin goes halfway between it. So what's half of pi over 4?
Pi over 8.
So your asymptotes are at pi over 8 and negative pi over 8. What's halfway between 0 and pi over 8?
Pi over 16.
Wait, what?
Close enough.
That doesn't make sense.
What's half of an 8?
No, not I get that. No. Oh, you got an 8.
Okay. Our asymptotes, or sorry, our period is pi over 4.
Yes.
The asymptotes will be placed at plus or minus 1/2 of your period.
That's right. Okay.
Because if you think, remember, the tangent always goes to the origin, so 1/2 the graph is on the positive, 1/2 is on the negative. So half of an eighth is a fourth, or sorry, half of a fourth is an eighth.
Okay.
In fact, our amp is at 3 over 2 and negative 3 over 2. Our A value, was it positive or negative?
Positive.
Which way is this going?
Down, up.
Down, up.
It's increasing from left to right. And then you just list out your stuff. Really, really fast.
By stuff, do you mean just like the?
Yeah, because when we get into the actual shift part, what we've been doing is listing out our ordered pairs, because it's easier to do the math as far as your shifting when you look at the ordered pairs individually, because it's a little bit cleaner.
Okay.
Listen,
How'd you get the factors?
what's half of an eighth?
Now put quotation marks on quotation marks. So it's around the graph.
Because it's ish. Tangent graph.
Yes, ma'am.
Can you get, because that's what it's like, can you just take?
That's exactly right. That's exactly right. We do 36.
Yeah.
Wow. So 1/4 tangent pi times x. Your A value is a fourth. Your B value is pi. Your amplitude is a fourth. And your period is 1. Remember that B value, the A value, they're just scalars. And they're just scalars out there. You mark them up. What's half of 1? Where are your asymptotes? What's half of a half? And your amp-ish thingy. Okay, shall we start shifting?
Yeah.
No.
When you shift tangent, what do you think I'm going to add in?
HK.
What do you think it's going to look like?
Same as the sine. Same as sine and cosine.
Correct.
Nice. Don't forget the quotation mark judging.
Can an asymptote be shifted up?
Yes.
No.
Well, it's good.
No. Technically, wait, are they shifted up though? They're infinitely long, but they're still moving. What?
No. The asymptote is just where it is.
That's the real question.
Well, why are we
Wait
asking
a
this question?
second.
We
Yeah.
should be graphing rainbows. Give us ways to be graphing.
The funny thing is, like, the way that rainbows are formed, everybody's graph would be different. Let's do a multiplication.
Negative 2 tangent 4 of the quantity x plus pi over 2, all plus 3. So, what do you think we're going to do first?
AB, okay.
Subtract 3, yes. Subtract 3 divided by negative 2. Distribute and hope for the best.
How's it feel, Matt?
Anyway, I was about to start. I almost wrote negative 3 divided by 2. So it's been a long day. A, negative 2. B, 4.
H.
B, 4. And after.
Wait, so it's A equals to
Remember, if it's x plus h, that means the h value is negative. The k value always stays whatever the sign is.
Yes. The sign of
Means my amplitude is 2. My period is pi over 4. And then I have a shift left and a shift up. If your period is pi over 4, where am I going to place the asymptotes? Good. What's halfway between pi over 8 and 0? A value is negative. What direction are we rolling?
Up, down.
Yeah.
We're done.
No, we have to move it. Okay.
Oh,
Remember, this is my parent function, so I'm putting it as a dotted line. It's not there. It's there to help us give us a visual representation. So we do this again. When you're listing your ordered pairs for tangent graphs, it's usually easier to list them going from left to right and then put your asymptotes at the end. Negative pi over 16, 2, 0, 0. Pi over 16, negative 2, and then negative pi over 8, and pi over 8. So now I have to work with fractions again. So I have negative 1/16 minus 8/16. Negative 9/16 pi. 2 plus 3. Zero minus pi over 2. Minus a negative pi over 2, or is it just negative pi over 2? Oh.
That's the
Negative?
Okay. 0 plus 3.
3. 4.
Okay, Cooper. That's Joe, because he's not here. 1/16 minus 8/16. Negative 7/16. And 1. Negative 1/8 minus 4/8. Negative 5/8. Everybody okay with how I'm doing, just individually changing the fraction and just putting them together? Yes, ma'am.
It still works if you just use those 3 points, right?
That's when you're doing tangent graphs, you're still finding 5 things: 3 points and 2 asymptotes.
Oh, you're shifting the
Yes. 3 points and 2 asymptotes. Yeah, you notice you gotta move the asymptotes. And then pi over 8 minus 4 pi over 8. So now we know that the furthest right our graph is going to be is at negative 3 pi over 8. Everybody okay with that? Negative 3 pi over 8 is still further to the left of pi over 8. So all I have to do is just place it. The other asymptote is going to be at negative 5 pi over 8. I've got a 0 spot, which is going to be my, where it's going to go through. I know the maximum up it's going to be is 5. And I have my other 2 points. I have it at, going from left to right, is going to be at negative 7 pi over 16. This is at negative pi over 2. And this is at negative 9 pi. Oh, I had that backwards, sorry. Sorry, it's negative 9 pi over 16. And then this is at negative 7 pi over 16. Okay. And now you have your other points. 5, 3, 1. Now, if you want, and some people do this, when you make your table, put your left asymptote, then your 3 points, and your right asymptote if you want. That way you know where they're going to go, if you put them in order that way. Yes, ma'am?
Why did you keep it on the bottom?
It's the new line that it changes through.
Oh, okay.
It's like the new 0 line, if you will. It's just an easy way to count it. That's all. I mean, it doesn't technically have to be there, but you know that's where you're counting up towards. That's all.
That's good.
Yeah, they count. And you're done. Really, it's the same thing we did yesterday, but instead of being all wavy, we're all lightning bolty. Yes. He's worried about watching basketball.
Oh, yeah.
Do you want another?
No.
Be good.
That's a lot of colors.
68 for a second, I want 3,000.
Yeah, that's
68. Oh, wait, I thought that.
Tomorrow, like I said, I'll probably do a whole bunch of combinations of the graphs themselves with all the shifts. Also with writing the graphs given like a amplitudes and periods, let's try and work ourselves backwards. And then on Monday, we should be able to tie it all together. I'm thinking we're probably going to be able to test out on this stuff Tuesday, Wednesday at the very latest. I'm still thinking it'd probably be all right to go Tuesday, but we'll play it by ear. We'll do reciprocal. The test itself will cover 14, 3, 4, and graphs. We'll have we'll have simplify, verify, solve the equations, and then graphs. Yes, sir. Yeah. Yeah, Bill. I've got a couple things put together. I'll give it to you guys tomorrow. Which ones was it? It was 46 or 42? Then it was these.
36, 37, 40, 45, 45, 30.
So here's one of them.
Except for 44.
And then what's the other?
37 and 40.
So which one did we do? 44?
45 to 48.
There you go.
We're not doing 49.
No, we don't need
You guys have this kind of work anymore, you do.
36 and what to the page?
It was 8:36 and 8:45.
45 or 35. My brain needs to get.
You're hot.